Let's look at two more examples of how to graph systems of inequalities on the coordinate plane. In the example shown on this slide, we have a system of two inequalities. The first is y is less than 2/3 x minus 1. We'll graph this one in blue. The boundary line is y equals 2/3 x minus 1. And since it's written in slope-intercept form, we can see that the slope of the boundary line is 2/3, and the y-intercept is 0, -1. So we'll start at that y-intercept and then count up 2 and to the right 3, using rise over run as the slope to identify more points on the boundary line. Because we have a less than symbol in our inequality, those points on the boundary line are not solutions, and we will indicate this using a dashed line. Now to determine which side of the boundary line contains solutions, we can test a point. The origin is convenient if we let y equals 0 and x equals 0 in that inequality. 0 is less than 0 minus 1 would be false, so the origin is not a solution. Therefore, the solutions are all the points on the opposite side of the boundary line from the origin. Let's move to the second inequality in the system. 3x minus 2y is less than 4. We will graph in red. The boundary line is 3x minus 2y equals 4. Now, even though this equation is written in standard form, it would be difficult to graph the boundary line using intercepts, since the x-intercept would not be a whole number. Instead, let's rewrite the equation in slope-intercept form. We can do this by subtracting 3x on both sides, and then dividing both sides by -2 to obtain y equals 3 over 2x minus 2. So for this line, we have a slope of 3 over 2 and a y-intercept of 0, -2. So we start at the y-intercept and then count up 3 and to the right 2 to find some more points. Again, we have a less than symbol in the inequality, so those points are not solutions, so we'll draw a dashed line for our boundary line. To determine which side of the boundary line should be shaded, we can again use the origin as a convenient test point. In this case, if we substitute into the inequality, we have 0 minus 0 is less than 4, which is true. So the origin and all the points that are on the same side of the boundary line as the origin are solutions. Now if we examine the graph of both inequalities together, we can see that the overlapping area between these two shaded regions would be this wedge-shaped region between the two boundary lines. And so we'll shade those points in green to indicate that those points make both inequalities true at the same time. Therefore, those points are the solution to the system. Our final example actually contains 3 inequalities in the system. We can still graph the solutions on the coordinate plane using the same process as before. Our first inequality, which we will graph in blue, is y is greater than or equal to x. The boundary line is y equals x. This line has a slope of 1 and a y-intercept of 0, 0. So we'll start at the origin, and then using the slope of 1, we can quickly find more points that fall on the boundary line. In this case, we have a greater than or equal to symbol, so the points on the boundary line are solutions of the inequality, so we will graph a solid line. Now, since the origin itself is on the boundary line, we can't use it as a test point to determine which side of this line should be shaded. So let's pick another point. 0, 1 is relatively simple to use. So if we let y equal 1 and x equal 0 in the inequality, 1 is greater than or equal to 0 would be true. So we would shade all the points on the same side of the boundary line as that point 0, 1. Moving to the second inequality, we have y is less than or equal to 4. We'll graph this in red. In this case, the boundary line would be y equals 4, which is simply a horizontal line. And since we have a less than or equal to symbol, the points on that horizontal line, y equals 4, are solutions. So we'll draw a solid line at y equals 4. We can also tell from substituting 0 in place of y that the origin would be a solution, since 0 less than or equal to 4 is a true statement. Therefore, all the points below that red boundary line are solutions of this inequality. Now let's move to our third inequality. X is greater than or equal to -5. And we'll graph in black. First, the boundary line x equals -5 would be a vertical line. And because of the greater than or equal to symbol, we need to use a solid line to indicate that points on that boundary line are solutions. Again, if we think about the origin, if x is 0, then the inequality 0 is greater than or equal to -5 would be true. So points to the right of that boundary line, along with the origin, would be solutions of this inequality. Now we can see, as we look at this graph, that the overlapping region among all three inequalities would be all points that are to the right of that vertical line, below the horizontal line, and then above and to the left of the blue diagonal line. So we can see that those points fall inside this triangular area of the coordinate plane. So we can shade those all in to indicate that those points are the solutions to this system.